Hi friends, today I will discuss the shaded pole induction motor. The shaded pole induction motor construction is like this. It will have a stator and it will have a rotor like this. This part is called the stator and this is rotor, and this rotor is squirrel cage rotor. The specialty of this is the main core of this motor is divided into two poles like this. So at 3/4 of the each pole there is a small cut in the core like this. Similarly in the other pole also. So then we put a copper shading band over the small portion of the pole here and similarly here. When we give the single phase AC supply to the main winding connected to this core like this, so then there is a sinusoidal flux produced, and that sinusoidal flux will be divided into two parts. One is that is links with the unshaded portion of the pole, while the other flux or remaining flux links with the shaded portion of the pole. That is like this. Because of the Lenz's law, the shading pole opposes the main flux, that is like this. As a result, it produces some flux, and as a result, in the shaded pole region, the net flux will be less, whereas the flux in the unshaded portion is maximum. So the magnetic axis will be in the unshaded portion like this. When we take the AC flux that is produced, we have the totally three regions: 0 to A to B, B to C. So when we analyze it properly, from 0 to A, that is initial condition, that is maximum flux will be linked with the unshaded portion of the pole, while the flux linking with the shaded pole is less, so the magnetic axis is on the unshaded portion of the pole like this. When it comes to the AB, the rate of change of flux or the rate of change of current is less, so the opposition by the shaded pole is less to the main flux. So as a result, here the flux also increases in the shaded pole region, and main pole also there is a flux that becomes less density compared to the previous one. Now the axis of magnetic flux will shift from left to right like this. This is for AB region of the flux. Then when it comes to the BC region, so there is a steep fall of the flux here. So then we see that there is a less opposition by the shading ring or shaded pole. So there is a maximum flux density in the shading pole, while the less flux density in the unshaded portion. So as a result, the magnetic axis shifts from center to the right side like this. So the rotor follows the movement of the magnetic axis, that is from unshaded portion to the shaded portion. That is, the unshaded portion flux will lead the shaded pole flux like this. So as a result, the rotor of the shaded pole motor rotates from the unshaded portion of the pole to the shaded portion of the pole like this. Coming to the torque speed characteristic of shaded pole induction motor, so we find like this. This is the speed axis, that is the rotor speed axis. This is the torque produced in the shaded pole induction motor. When we observe properly here, the starting torque is only 0.5 times the rated torque of the motor, like this. And normally the rating of the shaded pole induction motor is 0.1 HP. Coming to the applications, so this is normally used for projectors, Xerox machines, table fans, hair dryer, tape recorder, etc. Coming to the advantages of this shaded pole induction motor, the cost of it is very less and capable of self-starting, and the construction is simple, robust in nature and more reliable. Coming to the disadvantages, it has very low starting torque, low power factor, less efficiency, high losses, difficult in speed reversal as it requires expensive copper rings. Thank you. Like the video and subscribe to my channel.